Today, we're going to start off with our literature discussion. We're going to start with the review articles. Both of these articles were pretty good, and I chose them purposely because of that. Neither are perfect, as no article can be, and you pointed out many of the errors in the perusal. And that's okay that they have them. The questions I want to raise about these are ones that often come up on debates of this sort of topics. Vaccines is another topic where it comes up. So if you have not considered the questions on this slide here, please take a moment, pause the video, and consider them for yourself before hearing my thoughts. These are not exactly scientific questions, so much as value judgments, and so considering your thoughts before hearing mine is certainly worthwhile. Go ahead and pause this and come back when you're ready. First off, given that basically all of the high-quality available science that we have on GMOs say that they're safe, and it is relatively biologically implausible that the mechanisms should be problematic, should we continue to do these studies? To decide that, we need to talk about the costs of each side. Those who tend to be risk-averse might say, let's keep doing studies since you can never prove that anything is 100% safe, so we must keep doing them. And as a value judgment, that is quite difficult to argue with. On the other side, we need to consider the cost. There is a monetary and resource cost to continuing to complete science that tells us things that we already know. Every study that we fund on GMO safety is resources that could be going to, say, developing new GMOs that solve problems such as golden rice or bananas, or of course to other unrelated fields as well. The main counterpoint to that is that the anti-GMO advocates will likely continue to put out their low-quality studies, and if the only studies coming out say that GMOs are dangerous, well, it might be worthwhile to continue to put out higher quality studies as well to ensure that people are getting good science as well as those pseudoscientific studies. So what's the right answer? I don't know. There probably isn't one, and therefore the answer is likely somewhere in the middle. Continue to fund safety trials on some new species while ensuring that an overabundance of resources don't go there, perhaps? Something along those lines. Though an argument can be made to go a bit further to one side or the other depending on your particular values for sure. Now let's move on to the next question. So the EU operates under what is called the precautionary principle, where effectively until you prove your GMO is safe, it cannot be introduced. This can be a very powerful tool, but it also has costs. It puts the burden of safety trials on the company that is set to make money off the crop, which can certainly be considered a good thing. However, it also means that it slows time to market and results in a lot of repetitive trials. It also is essentially working off the assumption that, quote, this could be dangerous, which could pit public opinion against it. I'd argue that if we know something is generally safe, that I'd rather extract that money from corporations in other ways and put it to better use, but similar to our previous section or questions, levels of risk aversity may vary. It could be argued, why even bother with GMOs? And while that goes a bit beyond the scope of the health sciences, the general answer is growing more food for cheaper so that we can feed more people. In the absence of any sort of population control, we are absolutely going to need to find more methods for food creation, and that's where this comes in. So I wanted to comment on something that a student commented on. So I'll give you a second to read this. And go ahead and pause it if you need more, because you likely do. So in both of these cases, we are mutating the genome. On one case, though, it's a targeted change where you're making one change, where in the other, it's through many random changes. But we only really seem to care about the regulation on the one targeted change. I don't have a specific answer for why we care about transgenesis but not mutagenesis, other than perhaps a tomato with a fish head on it makes for better marketing. Or perhaps due to the timing. Transgenesis came out in the era of social media, while mutagenesis has been around a lot longer. And of course, there are people who speak out about both. But either way, it is something to think about and a thought I'd pass on. Now let's move on to the research article, which is really more where my interest here lied. I just wanted to make sure you also had kind of a general view of where the research sat kind of across the board. So here are some questions I want us to consider for this article. If you haven't had a chance to think about any of these, please take a moment to do so. Go ahead, pause the video, and come back when you've had a moment. For completeness, I'm going to go ahead and put this slide up, but for brevity, I'm going to refer you back to the blog article that I posted with lots of quotes in it. I think that it does a really good job of talking about all of these. And if you can't answer any of these questions after reading that, then come to class and let us know. Or if there's just any part of this where you want to talk about it a bit more, where it's not clear. We're actually going to talk about some of these in today's lecture as well, such as dose response and a couple others. So now let's talk about these sort of wider implications. So let's talk about this first one. Why did this very low quality article get so much press? So being anti-GMO has become a bit of a pride point for many subgroups of the population. Politically, it tends to kind of be a left-leaning pseudoscience, but it does cross both sides of the aisle. The population concerned with healthy eating is where this really takes on the feel of almost a religious belief, though. And this is a group of people who are near and dear to my heart, and they definitely get many things right, but this is just not one of them. And when any belief of any kind starts to take on this level of fervency, people will latch on to any research, even that backs that belief, and they won't judge it as harshly as they should. This is a form of motivated cognition that we're going to talk about today. I'd also argue that the pictures of the animals were so graphic and so emotional that they really played upon people's fear. Any article that can play upon fears is going to get more press than one that reads dryly. It was argued that that was the reason why he let these poor creatures go so far past what is considered humane. And I'm prone to believe it, since the pictures really add no scientific merit to the article, even if there was a reason to keep the animals alive longer, and there wasn't. Now let's look at the second question. Would your journal quality measures have saved you from accepting this paper before the retraction? This second question really feeds directly from the first, and in some ways is an answer to the first. The other reason it got a lot of notice is that it was in a legitimately trustworthy journal, or at least it was a trustworthy journal. No one is quite sure how it made it through the peer review process. Now, remember that most of the time, only 3 reviewers will look at the paper. This is generally enough to catch most issues, as the reviewers don't want to let bad science through. But if the selection of reviewers isn't careful enough, and it happens that all 3 let things slip through, something like this can happen. It then has to undergo the more wide peer review process of all the scientists in the field looking at it and deciding if it's worth using, believing, citing, or actively speaking out against in this case. And remember, reviewers aren't paid for their time. We get to throw a, quote, I reviewed X number of papers on our promotion file, but it isn't really considered particularly prestigious, and no one's going to get promotions just for doing a really, really good job of reviewing. And so sometimes this is going to happen. It doesn't mean that peer review isn't important and that it isn't largely successful, it's just that it isn't perfect. The journal at least retracted it, but the damage was sort of done, and if a journal has to do this too often, it will definitely damage the reputation of the journal, and so they do have incentives not to allow it. One would certainly hope that, for instance, they don't use those reviewers anymore. Now, moving down to this question. Did retracting it from the journal stop it from being used by anti-GMO advocates? So this question too is about retractions. And this is really, really important, especially in the current era of preprint releases. It also kind of piggybacks off what we talked about with the studies on gluten intolerances, even though that wasn't a retraction, but rather an improvement. Once an article or an idea is out there, retractions often don't get nearly the impact that we'd hope. People tend to remember the information the first time that they are given it and don't update appropriate when more information is given. This is another cognitive bias that we'll be talking about today. But often it's just that the retraction doesn't make the news the same way that the initial paper did, and so people never even find out about it to begin with. Not to mention biased websites, which are furthering particular agendas, will specifically discuss papers that came out on their side and then never update if a retraction comes out. A group called Retraction Watch does a ton of good work on this. They keep track of retractions and try to publicize them. So there are definitely lots of other reasons here. I'm just discussing the things I see as the biggest. If you have other ideas that you want to check in on, feel free to bring them up in class. Now, lastly, why should we care about bad studies like this getting published if it's only in low-quality journals, which this one eventually ended up in? When this did eventually get published and not retracted, it was in a low-quality journal. So is this something we should even be concerned about? After all, if it's a bad journal, people just won't believe it, right? And of course, the problem with that is that's not true. People absolutely will believe it. They'll say, I read about it in a peer-reviewed journal. And they won't know the things that we talk about in this class, and won't know that it's meaningless if the journal doesn't do a good job with the process. Additionally, as we talked about in the Journal Quality Day, often these low-quality, pay-to-play journals are free to the public, while the higher quality research is behind expensive paywalls that you can't get to unless you have access somehow. This creates a massive problem in scientific literature where we're giving away bad misinformation while hiding our best information. It's not hard to see where people who have not been taught the skills to sort through all of this might come up on the wrong sides of these issues. And that's one of the reasons I think it's hugely important never ever to write off a person's belief as being, quote, uneducated. Because unless you are an expert in the field, everyone is relying on the experts. It's just who you deem is an expert that sets your belief system. So always make sure you're paying attention to the consensus of experts and be very, very careful on who you trust. A quack can make it through grad school or med school or any other professional school. It happens. And so often you may need to consult many experts to know if someone is truly believable or not. And it's why I included that blog post summarizing the comments of experts for you. Things like that can be immensely helpful in sorting through articles, so you don't have to have the expertise to sort through it yourself, but you can still decide whether you're going to trust any one particular expert or not. This came from the blog article with all the quotes, but maybe take a moment, pause, and read through it one more time, because I think that this is really important. And if you don't want to read through the whole thing, just read the bolded parts. So I think that this perfectly summarizes the concerns on bad science, either slipping through peer review cracks and then getting retracted, or being published in bad journals. I highlighted the part that really summarizes this point, and something to keep in mind when listening to people talk about topics. Every issue you can think of, but especially hot topics like GMOs and vaccines, have papers like this out there, and they make big, huge waves in the non-science crowds. And very often, when people will say, quote, educate yourself, they are talking about reading these truly terrible papers. Now, what are we going to do about this? That's hard, and there isn't any one answer. Revamping the publication process to compensate people and reward more stringent peer review could help. But that's not going to help with these poor quality journals to begin with. Making high quality journal articles free would go a long ways in making access to information equitable, but it isn't going to do away with motivated cognition. Likely a massive change in the entire way that publication works is probably necessary to truly fix the problems, but those are some ideas that would help in the meantime. I also think that teaching people about bad journals and bad science and how to spot them makes a difference in my totally and completely unbiased opinion. Now, I'll leave you with that and the question of what else could we do to help with this issue, and we'll move on with our topics of the day in the next video.